Welcome to this introduction to heuristic algorithms. We'll answer three questions in this video. First, what are heuristic algorithms? Then, why are they useful? And what are some design patterns for heuristic algorithms? As George Polya said, heuristic reasoning is often based on induction or analogy. And this captures the essence of how heuristic algorithms solve problems. They rely on intuition and practical shortcuts rather than exhaustive or infeasible calculations. Here's a simple example of heuristic reasoning. Given the sequence 4, 5, 6, 7, 8, what do you think comes next? While the answer seems obvious to us, the underlying reasoning relies on a heuristic, induction, or generalizing by recognizing a pattern. And this pattern might be a regularly increasing sequence of numbers. Another example for heuristic reasoning is to use analogies. Analogies are similarities between the relations of problem components. So here we see a set of 6 problem instances, and each problem instance consists of 2 components, a geometric figure or shape and a number. Can you guess what the number is for the last problem instance by looking at the other problem instances? Maybe some of you find that the number might be something like the area of this shape. Heuristic algorithms are also everywhere in AI. And these AI algorithms help us to make decisions like finding a job, suggesting who to date, or recommending what to watch next. These algorithms simplify the complexity of real-world decision-making. One core heuristic in AI is the assumption that similar inputs should lead to similar outputs. This principle is foundational to many AI and in particular machine learning applications. We can turn this AI principle into an optimization problem by measuring the deviation between outputs obtained for similar inputs. Indeed, AI often boils down to optimization, that is, tuning model parameters in order to maximize a performance measure, some measure of performance. But this optimization process is far from simple or straightforward, which is where heuristics come in. Here you see a simple visualization of the loss landscape obtained for a deep neural network, which are a popular class of models used by current AI systems. And as you can already guess from this left figure here, finding the exact optimum in this highly complicated loss functions is challenging. And AI systems, they use efficient optimization algorithms to find this minimum. So AI means to optimize model parameters in order to maximize performance or minimize error. So finding the optimal choice for the model parameters of an AI system is typically intractable. There are so many parameters, like these modern large language models, they use hundreds of billions of parameters. And moreover, this performance measure as a function of these many parameters is highly nonlinear and non-convex. So there's simply no way to use an optimal optimization or to use an exact optimization algorithm that precisely picks or finds or searches for the optimal choice of model parameters. Rather, we need to use some heuristic ideas or heuristic optimization methods. And here I would like to point out a recent definition that I found for heuristic algorithms or heuristic, which says a heuristic is a strategy that ignores part of the information in order to make the decisions more quickly or even more accurately than more complex algorithms. So in the AI case, this ignoring part of the information means to approximate the loss function or the objective function, this performance measure that we want to optimize, locally by a linear function. And this is the idea of gradient descent. So we around the current guess for a good parameter values or a good choice of parameters, we approximate the objective function by a linear function, and then we try to minimize this linear function in a small neighborhood around the current point. And using this minimum, we continue as the next choice for the model parameters. And a variant, very widely used variant of gradient descent known as stochastic gradient descent refines this process by estimating the gradient, which is typically obtained by summing over many data points, billions of data points, and estimating this sum by a randomly selected subset of data points. So stochastic gradient descent is obtained from gradient descent by using a stochastic gradient estimate, and this stochastic gradient estimate has the advantage that it needs way less computation. But even if we have now an efficient way to estimate the gradient, another aspect that needs some heuristics in optimization for AI is the learning rate. So gradient descent is based on a local linear approximation, and the question is, how large should this local neighborhood be? And this size of the local neighborhood is essentially determined by a parameter called the learning rate. And if this learning rate is chosen too large, then this gradient descent steps, they might never converge to a minimum or even local minimum, because they might overshoot the minimum, loosely speaking. On the other hand, if this learning rate is too small, we might make too little progress within a given amount of time. Normally, we don't want the model to train for 100 years, but we want to have a trained model within a few seconds. So we can only afford a few gradient steps. And for this, the learning rate should not be too small. And here one heuristic is to use varying or adaptive learning rates. For example, we decrease the learning rate as the iterations progress in order to make sure that we make good progress in the beginning, but when we are already close to a minimum, we do not overshoot then. So that's why we need to make the learning rate smaller towards increasing iterations. Okay, so we have now one example of a heuristic algorithm, which is stochastic gradient descent, which is used to train AI models. It's maybe the most widely used algorithm to train AI models, but typically it never delivers the exact optimal choice for the model parameters. So why is it still used? Well, it strikes a balance. It's just good enough. It makes optimum use or makes good use of the available computational resources in order to find an approximate solution or an approximately optimal choice for the model parameters. Okay, so to wrap up, I have now discussed a simple example or a very popular example of a heuristic algorithm, which is stochastic gradient descent. And more general, heuristic algorithms are used to solve hard optimization problems. So there's typically no formal guarantee that they deliver an optimal solution, or even a guarantee on the suboptimalities might be lacking, but they work well in practice. So that's exactly how we use currently AI systems. We train those models using stochastic gradient descent, and the results are good enough. So for example, you get entertaining answers from ChatGPT. So the model has been trained sufficiently well, given available computational resources, although those resources, they are quite massive for these large language models. But we would have no way to find the precise optimal choice for the model parameters. So that's why we use heuristic algorithms. We sacrifice optimality or optimality guarantees and bias more efficient algorithms in practice. Yes, so that's why they are useful, because they require less resources, less compute time, less memory or storage than optimal methods, and still deliver reasonable solutions. Okay, and yeah, to remind you about the the intuition or how a gradient descent is derived or constructed. It's based on approximations. It's based on a local linear approximation, but there might be other ways to approximate a problem instance or parts of a problem instance. And so approximation is one main design pattern for heuristic algorithms, and two others are induction, so inductive ideas, inductive reasoning, when we look to find a pattern in a sequence of problem instances, which is exactly a machine learning problem, by the way. Machine learning is based on training a model to find a pattern in a training set. So actually, the quintessence of machine learning is a heuristic. And then another design pattern is analogies. So we use analogies between different domains to transfer knowledge from one domain to the other domain. Okay, and to learn more about heuristic algorithms, you can check out this excellent book by George Polya, How to Solve It, or my own textbook on the basic concepts of machine learning. And as I said, machine learning is a prime example of applying heuristic ideas. Thank you for watching, and don't forget to like, subscribe, and comment below. See you next time.